And therefore, we also need to know that acceleration is denoted by a small letter a. Acceleration, we denote acceleration. Acceleration is denoted by a small letter a. This is the symbol for acceleration. It is not the SI unit. We can even write it here. So we have A for acceleration, a small letter a. And therefore, we can go ahead and therefore say, when we want to get the change in velocity, will simply be given by the final velocity minus the initial velocity. We'll have the final velocity. For us to have the change, we have the final and the initial. So the final velocity minus the initial velocity. That's what will give us the change in velocity. And therefore, we can go ahead and say that acceleration will therefore be equal to change in velocity, which is final velocity minus the initial velocity. Final velocity, we subtract the initial velocity, we divide by the time taken. This one will give us the acceleration. So acceleration is the rate of change of velocity, or simply the final velocity minus the initial velocity divided by the time taken. And therefore, we also need to know the symbol that we use to denote the final velocity. Final velocity, the final velocity, we denote it using a capital letter V. We use V. Then for the initial velocity, we use a small letter U. So ensure that it has the tail. And as we know, for time, the time, we use a small letter T for time. And therefore, from this formula, we are going to have that acceleration, therefore, acceleration A, the acceleration A, therefore, will be equal to final velocity V minus the initial velocity divided by the time taken. So this is our acceleration, the change in velocity per unit time, or the rate of change in velocity. So we have the final velocity minus the initial velocity divided by the time taken. That's what we have for acceleration. Therefore, we can also continue and say, now that we know that acceleration A is change in velocity, that is V minus U all over T, we also need to get from this, we will be able to know whether acceleration is a scalar quantity or a vector quantity. We know that this change in velocity, the velocity is a vector quantity. So we are having a vector quantity, and we know that time is a scalar quantity. So a vector quantity divided by a scalar quantity, we also get a vector quantity. And therefore we say that acceleration is a vector quantity. Acceleration is a vector quantity, meaning that it shows both direction and magnitude, both the direction and magnitude. So that's acceleration, change in velocity per unit time. Then we have seen that acceleration is a vector quantity. We also need to get the SI unit. What will be the SI unit of acceleration? The SI unit of acceleration. So we get the SI unit from the formula, whereby we are saying acceleration is the change in velocity, V minus U, divided by the time taken. And we know that V minus U, the unit for velocity, the SI unit, we said is meters per second. And then the SI unit of time is seconds. So when we divide meters per second, divide by the seconds, we are going to have meters per seconds divided by the seconds. This is always over 1, a whole number. So we'll have meters per second multiplied by 1 over second. So we are going to end up getting meters per second square. And therefore the SI unit is meters per square second. So the SI unit of acceleration is meter per square second, meters per square second, which we write it as meters per square second, or you can write it as meters per square second this way, meters per square second. So the SI unit of acceleration is meters per square second, which you can write in this form or in the other form, or the full ones, that is meter per square second. So that's what we have for acceleration. And always note, whenever you want to get the SI unit and you have a formula, you need to get the SI unit for the numerator, that is the change in velocity, which is meters per second, and then the SI unit of the denominator, that is time, which is seconds. And when you divide, you are going to get that the SI unit of acceleration is meters per square second. Now, again with acceleration, let's have the formula here still. Acceleration, we've said, is the rate of change of velocity. Now, if we have a body moving with a constant velocity, if the velocity is not changing, for a body moving at a constant, velocity, that means that the velocity is not changing. The initial velocity is equal to the final velocity. That is, the final velocity is equal to the initial velocity. Therefore, it means that the acceleration, the acceleration for such a body is zero. The acceleration is zero. This is since because, for example, if we take our initial velocity to be 20 meters per second, that body is moving at a constant velocity, and therefore the final velocity again is also 20 meters per second. The final velocity is again 20 meters per second. It means that acceleration will be final velocity minus the initial velocity divided by the time taken. So we are going to have the final velocity 20 meters per second minus the 20 meters per second. We divide by the time taken. Time taken can be 2 seconds, it can be whatever the number of seconds. So we are going to have it as, that is for a body moving at a constant velocity. Therefore, it means that acceleration will be 0 meters per second, that is the change, divided by the time taken. Any number, a 0 divided by any number is equal to 0. And therefore, it means that the acceleration will be 0 meters per square second. So for a body moving at a constant velocity, that is, final velocity is equal to the initial velocity, the acceleration of such a body is equal to 0. The acceleration of such a body is equal to 0 because when you get to subtract, you get 0 over a number. T can be any number that is which is not less than 1, and we are going to have that our acceleration therefore is 0 meters per square seconds.